or maybe not even aware of it. And then I have two use cases that I would like to go over, Volvo and Daimler AGA. And I selected those specifically because they have content related to like Internet of Things. And then finally, I'll talk a little bit about Disruptive Technologies Lab and some of the things that we're doing at UWM. So let's have a couple quotes here. Here's the CEO of Google. Machine learning is a core transformative way by which we are rethinking everything that we're doing. Let's take a look at the CEO of Microsoft, a proud UWM alumni. Artificial intelligence is the defining technology of our time. It's going to be AI at the edge, AI in the cloud, AI as a part of SAP applications, AI as a part of, in fact, even infrastructure. So let's start out with a question that I get on occasion. Will robots take my job? And I want to rephrase this question a little bit differently, because if you take a look at through history, not so much AI, but technology, and more specifically, automation has changed how we've done things. So years ago, there used to be telephone operators. We don't have them anymore. There used to be bowling pin setters. We don't have them anymore. We used to have people that would cut ice and deliver to your house. We don't have them anymore. So the question that I want you to think about as I go through my presentation isn't as much about, will robots take my job, but how will the technology and how will the automation change what we do? And the reality is that, at least from the research that I've seen, upwards of 40% of jobs over the next 5 or 10 years will be modified because of this. But what ends up happening is in every technology revolution is that some of those jobs, yes, are in fact eliminated, but new jobs come to the forefront. And that's what we have to be thinking about from our perspective as a university. And we'll talk a little bit about more of this as I get into the presentation. So here's a couple headlines. We're going to talk about the hype cycle kind of related to AI. Here's a Wall Street Journal headline that says every company wants to become a tech company, even if it kills them. Here's a Forbes headline that says, on your marks, business leaders prepare for the arms race in artificial intelligence. If I was an executive or if I was a C-level person, you know, they're seeing this wave of change that's coming in and starting to be concerned with it. But what you have to do is identify where we are with respect to some of these technologies. If you're not familiar with it, Gartner produces every single year what's called the hype cycle of emerging technologies. This is going back a couple of years, but I think it gives a snapshot of some of the ones that we're going to talk about today. As an example, on the spectrum, we have augmented reality and blockchain and IoT platforms and virtual assistants. And we go through this phase where there's you know, innovation triggers. There's the peak of inflated expectations. You see them on all the magazines like Wired and stuff like that. Then we have the trough of disillusion, where those technologies don't deliver on what they had promised. And then we kind of go through the slope of enlightenment and finally the plateau of productivity. So if we take a look at some of the technologies that are highlighted, and what's interesting, this is already, again, 2 years old. This is 2018. So general AI is more than 10 years out. And we'll talk a little bit more about that later on. I'm going to specifically in my presentation reference narrow AI, very specific applications. Level 4 self-driving autonomous vehicles are still on a mass scale, probably 10 years out. Conversational AI platforms, 5 to 10 years. IoT platforms, depending on what you're looking at, might be at 5 to 10 years. And now we're getting into a shorter range here. So virtual assistants, 2 to 5 years. So if this is already 2 years old, I already have an Alexa device on my phone. I have an Alexa device in my kitchen. I have a Google Assistant in my kitchen. My students at UWM develop voice applications for these. So some of these technologies are now coming to fruition. Deep learning neural networks, which is kind of the root of machine learning, is 2 to 5 years out. So even though there's hype associated with a lot of these technologies, in the next 5 or so years, they're going to be things that we're going to be using in our factories. They're going to be things that we're going to be using on our phone and in our homes and stuff like that. So we just need to be aware of them and kind of where they sit on this spectrum. So let me give you an example of that. I pulled this out because I think it's very interesting. Here's a headline that says, we are very close to a peak for fintech. There are more than 10,000 startups trying to jump on this particular boom. So fintech is sometimes associated with artificial intelligence. And what's interesting about it is I think this time regardless of what's happening with COVID-19, which I think is an anomaly, a black swan event, is that we are at a very transformative time, almost analogous to what kind of happened with the web many years ago. There was Amazon.com, and then there was Pets.com. One of those is very successful today. In fact, delivers a lot of products and goods that we need on a daily basis. And one of them was unsuccessful. And then we also went through another technology change where we got the mobile device that we have in our pocket, and to lesser extent, social media, which is our mechanism for how we communicate right now. I think we are in a very similar circumstance with some of these technologies now for artificial intelligence, blockchain, and IoT. So the reason I included this slide is because in 5 or 10 years, there's not going to be 10,000 of these startups, okay? Some of them will be very successful, like an Amazon.com. Some of them will frankly just not have business models that don't work, and they will be like Pets.com. But some of them will be like Uber or whatever successful mobile platform that there is. And as a consequence, a significant amount of economic activity and wealth and opportunity for us will be created. And the products and services that we expect on a daily basis will basically be enhanced. So I wish I could say that I have a crystal ball and tell you which are going to be the winners and losers, but there's going to be this wave. There's going to be this wave, and it's going to make our lives better because of it. And there's going to be a significant economic boom, I think, out of these activities. So let's start with a couple definitions. What is artificial intelligence? I'm going to try and keep this very simple. AI is a simulation of human intelligence processed by machines, especially computers. The process includes learning and reasoning, okay? This is the definition that I'm gonna kind of drive home. Even a simpler way to say it, it's a program that can sense, reason, act, and adapt. The difference between AI today and just a basic computer program is that we are not creating an if-else statement. This is something that can learn on its own, and we'll talk a little bit about that when we get to the machine learning aspect. It's something that we can feed experiences. It's something that we can feed data. It's something that we can feed images or voice, and then it can learn from those particular circumstances. If you're not comfortable with that definition, I want to talk a little bit about some of the characteristics of AI. And I want you to think about autonomy, the ability to perform tasks in a complex environment without constant guidance by a user. Again, this is not a program where we're saying, if this happens, do this experience, or if this else happens, do this experience. This can essentially operate on its own, and self-driving vehicles are certainly one of those areas. And then adaptivity is another characteristic that I want you to think about. It's the ability to improve performance by learning through experiences. That can be feeding it data, that can be feeding it images of cancerous cells and benign cells, and then being able to determine treatment for a particular patient. So these are the characteristics that we have of traditional AI today. So let's take a look at the taxonomy of AI. I don't think I said that right, but in a bigger picture, you have computer science, or I'm from the School of Information Studies, so we have this big sphere right here. Inside of there lives what I would call essentially AI. Inside of AI, we have the concept of machine learning. Inside the concept of machine learning, we have deep learning, which is kind of the core technology behind what's happening with self-driving vehicles. And we'll talk a little bit about some tangible examples of these, but I also want to highlight another sphere that we have in here. So we have data science. And a little bit we'll talk about what's the difference between big data and machine learning and how they are kind of correlated together. If you have data and you're doing linear regression on that data, you're in the data science camp. If you're starting to add in machine learning algorithms and deep learning, you're in that middle spot right there. And that's a sweet spot where we're taking knowledge of machine learning and deep learning and artificial intelligence and applying it to all the data basically that I have. And we'll talk a little bit about that more. So you can be on the data science side and have nothing to do with artificial intelligence or machine learning. Or you can be in that middle spot and capitalizing on these two pieces basically coming together. So what is the definition of machine learning? Machine learning is an application of artificial intelligence, again, that provides systems the ability to automatically learn. That's the key. and improve from experiences without being explicitly programmed. Okay, again, we don't have to have if-else statements in order to be able to determine that out. And not to get too immensely technical about it, but I want to talk about kind of the 3 areas underneath the umbrella of machine learning. The first one is going to be supervised learning. And what I want you to think at a very basic level associated with this is that if we know the classification of something, this falls under the supervised learning aspect. So we can create a machine learning algorithm, and we can have some training data, and we can have pictures of dogs, and we can have pictures of cats, and we can feed that, and now we have test data. And that algorithm should be able to tell us if that's a picture of a dog or a picture of a cat. Now, that's not very practical, but what would be some applications that could be developed in this particular area? Fraud detection, email spam, image classification, customer retention, diagnosis. Again, we could feed images of tumors and benign tumors and then have the algorithm determine if it's cancerous or not. Forecasting, predicting, insight. So if we have classifications of those characteristics, we can create machine learning algorithms that provide us. We go over to the other side, unsupervised learning. Let's just say we don't know what the classification is, but we can cluster things together. And an example would be is I'm a Netflix watcher, and I really like the new Tiger King series. Or I'm a Netflix watcher, and I really like documentaries. So we're clustering my preferences and preferences of people similar to me in order to be able to put together content recommendation systems. So let's just say I watch a lot of documentaries. I log into my Netflix account, and it says, here's another new fantastic documentary that you might want to like. So we're clustering items together. We're trying to gain insight from the data that we have. So this can be, in terms of application, customer segmentation, target marketing, content recommendation systems. And then we also have some other ones in terms of big data visualization. Again, we're trying to underline the structure of the information that are inside of there. So if we know the classification, we're in supervised learning. We know that there's some correlation or clustering of the data. We might be on the unsupervised side. And then the third area is basically reinforced learning. And this is real-time decision making. So a classic case of this, and we're going to see this later on in the slide deck, is something that's going to be used in self-driving autonomous vehicles. It's taking a lot of information in terms of signage and obstacles in the road, and it has to make decisions. So here we're also learning tasks, we're doing skill acquisitions, and this would be something that you would use potentially on the manufacturing floor in terms of robot navigation. So it has to make real-time decisions in those particular circumstances. And then there's algorithms and research behind each one of those. So let's talk about the difference between machine learning and big data. You've probably heard this terminology basically before. And I love this comment from Scott Page from the University of Michigan. He says, companies are increasingly trying to harness the rolling hairball of data that they collect on a daily basis. I'm sure if any of you are living on a manufacturing floor, you're collecting statistical data on quality control, you're collecting inventory levels, and you're trying to store all of this. I want you to think about there is a difference between a lot of data and big data. And what I mean by that is the second definition is that machine learning, at the root of it, is in statistics. And what we want to be able to do is extract knowledge from our data. We might have streams and streams of data. We might have a lot of data. But big data really refers to being able to gain some knowledge or insight from what's happening on our factory floor, and in being able to use some of that. So I could have a totally separate presentation about having to clean our data, having to correlate our data, and use it in an effective way. So companies are struggling with this. I'm sure everybody's collecting massive amounts of data for a whole variety of things, and we'll see some of those in use cases right now. But the key point, go ahead.
Matt, hey, we have a question
Sure.
from one of our attendees. So what progress has been made in regards to training and putting these concepts in the local work setting?
Progress has been made. I guess the way that I would answer it is that large tech companies like Google and Microsoft and Amazon are working behind the scenes in order to be able to put essentially turnkey tools in place so that you can take the data that you have, clean it, and then gain knowledge from that. So I think it's a struggle. It's a struggle that every organization basically has to go through. But underneath the surface, a lot of these tech companies are trying to create systems so that you have the data, you can use their platforms, and then gain knowledge out of it. I'm not sure if that answers the question or not.
Sounds good. All right, go ahead.
Okay, thank you, Charles. Okay, a little bit. So how can businesses basically use AI? Well, it's going to change the way that we understand and interact in our customers. We're going to see that in the use case that we have. We're going to offer more intelligent products and services. We're going to see that in content recommendation systems. And then we're going to improve and automate business processes. We'll see that in the Daimler use case basically that we have. So this is what I want you to think about. What is the power of AI in businesses? So again, I started my presentation kind of tongue-in-cheek talking about will robots displace all of our workers? And some work will change. Some work will actually change. But rather than being concerned about all the work basically being displaced, what I want you to think about is AI as a powerful set of tools that will improve decision-making, operational processes, aspects of customer service, and more importantly, enabling employees to focus on duties of higher significant value. That's the key that I want you to take away. When you implement these solutions, you're going to be able to create higher value for your organization and then higher value for your particular customers. So let's take a look at that. And what I want you to think about is a successful implementation of AI in an organization requires two things. What do humans do very well? Well, we have some strengths. We have creativity, we have improvisation, we have dexterity, we have judgment, we have social and leadership abilities. Now we want to marry that with what machines do very well: speed, accuracy, predictive capability, and scalability. When you bring those two together in an AI solution, what you're able to do is increase humans' ability to have output. We're taking what we do incredibly well, what machines do incredibly well, and we're combining those together so that we can have higher yields of the outcomes basically that we have. So when I would work towards successful AI implementations is I would want to capitalize on these particular items. So let's take a look at a couple common applications that we're probably already familiar with. Self-driving cars is going to be a situation. We're going to see a use case on Volvo related to this. It's a combination of a lot of different AI techniques, right? There's going to be searching and planning. We have to go from A and B. There has to be computer vision in that circumstance to read the road signs, to read obstacles in the circumstance. There might have to be reinforced deep learning in order to do decision making about a ball that bounces in the road. There's rain, there's snow. And what's interesting in this is that all of these pieces have to work flawlessly together in order to be able to avoid accidents. And what we're going to see in the Volvo case is that they are collecting a massive amount of data in order to have more robust and refined systems. And this transcends to a lot of different other environments. So autonomous systems can be from delivery robots to flying drones to autonomous ships. So through Silicon Pastures, we just saw Angel pitch related to a flying drone company out of Illinois that has some proprietary technology and I think will be very successful in the future here. Let's take a look at another circumstance. How about content recommendation systems? So on a daily basis, most of the content that we interact with is personalized for us. Our Facebook, our Twitter, our Instagram feeds, our online advertising, music recommendations from Spotify, movie recommendations from Netflix and HBO are personalized. Maybe you're aware of it or maybe you're not, but every time you Google something, that is personalized to your situation. They're looking at your demographics and your past searches, unless you are incognito mode. They're looking at your location and they're offering up a unique search result for you. On the positive side, that's important. So On Fridays, I Google great fish fries near me, and it brings up Lakefront Brewery. So this is important. So the algorithms behind the scene that are determining that content, either through my Netflix or through my Google search, are basically based on those AI applications. Let's take a look at one more. How about image and video processing? So facial recognition is already a commodity that's used in many businesses and government applications. This can include organizing your photos. I can go onto my iPhone and I can search for pictures of myself or my son. If you've ever posted a picture out on Facebook, there's auto tagging on social media. There's passport control. I'm a part of Global Entry that allows me to seamlessly go through customs. So a lot of these applications are already in place. But what I want you to think about is it's not just on the social media and image recognition side. It can be used in autonomous vehicles to recognize other cars. And there's, again, going to be a whole slew of applications that are going to be built in this area. An example of it is wildlife population estimates. So we can take a snapshot, identify deer population in Wisconsin, and as a consequence have policies on whether we want to extend deer hunting season or whatever appropriate decision in that circumstance. AI can also be used to generate and also alter content. This is very popular now on the gaming side. So think about all the video games that require all the images and all the media and all the assets that are inside of there. There's generative adversarial networks that can generate a lot of this stuff and can streamline the development of basically some of those games. I'm not going to talk a lot about the negative consequences. There's some ethical issues that we have to deal with related to AI. Whether you like Big Brother or not, the DHS, this is already a year old now, basically says that we're going to have facial recognition in 97% of departing airports in the next 4 years. If you look over to China, they actually are, I think, ahead of the curve on this. Individuals over there can purchase food from their facial recognition. They have some public shaming of people jaywalking over there. There's a classic use case associated with that. So whether you like it or not, facial recognition is going to be a part of our daily lives, probably at least on the travel front over the next couple of years. So let's take a look at AI in manufacturing. And I want to highlight 4 areas before I go into the use cases that I have. Let's think about quality checks. So factories are creating intricate parts like microchips and circuit boards, and they're making use of machine learning, which equips AI with incredibly high resolution cameras. And the technology is able to pick out minute details and detect defects much more reliable than the human eye. Kind of an analogous associated with this, Domino's Pizza takes a picture of every pizza that comes out of their oven. Obviously, they're not an industrial manufacturer, but they're doing that for quality. And they trace all of those images. If you get a pizza from Domino's and are unhappy with that, they will trace it back to the image that they took of that. So again, they're collecting all of this particular data, which I think is interesting. So quality is on the manufacturing floor is going to be enhanced with machine vision. What about maintenance? So smart factories using machine learning to detect and predict defects in machining before any issue arise. This allows for predictive maintenance and can cut down on unexpected delays in those circumstances. You're monitoring temperature. You're monitoring the amount of time that your machine is running. And then you can, even in an unsupervised fashion, look for trends or categories and then identify if issues are occurring in terms of your factory equipment. 2 more areas that let's take a look at. How about faster, more reliable designs? AI is being used by companies like Airbus to create thousands of component designs in the time that it takes to just to have enter a few numbers in the computers. Autodesk, which I think is a partner in the Connected System Institute, can do what is called generative designs. And it can massively reduce the amount of time it takes to look at designs and then manufacture and test those new ideas. In a little bit, we'll talk about Daimler, which is using obviously 3D printing in order to create components and things like that. So both through iterations and then generative designs, we're going to get much more robust designs for the products basically that we have. And then last one that might be very interesting to individuals in the manufacturing sector, there's advanced manufacturing. There's a company called Preferred Networks. It's out of Japan. And they developed a robotic arm with a camera and machine learning software that, given a picture of a successful outcome and trial and error, can figure out a solution associated with that. Again, remember at the core of machine learning, we can feed it experiences, or we can feed it data, or we can feed it images, and then it can learn and develop from those circumstances. So this is actually pretty exciting. So let's take a look at two specific use cases in this area. I'm sure everybody's familiar with Volvo. This is out of a book that I have called 50 Successful Use Cases in Artificial Intelligence. And really, they're using machine learning to build much more intelligent cars. A little bit about the background. So they're a Swedish established company, and they're really known for their safety record. That's going to be the key piece as we look at this use case. And just like any automotive manufacturer, they're planning on launching 4 autonomous cars into the market by 2021. Now, if you go back and you take a look at the Gartner hype cycle that we took a look at, it said that level 4 self-driving autonomous vehicles, which means that the car has complete control, but you have a driver in that, is still quite a few years out. But what they're trying to do is assess the safety level connected with autonomous vehicles. And they're doing that by collecting a significant amount of data and then analyzing that. So let's take a look at that. So what is the problem that artificial intelligence is trying to solve in terms of Volvo? So Volvo is looking to keep their reputation as a world leader in safety, which is important moving forward with self-driving autonomous vehicles, right? So they care not only about their reputation, about their past, but they want to be known as the most safe self-driving autonomous vehicle on the road. So they're leveraging what they're good at, and then what the trends are that are coming down the pipeline. So let's take a look at how they're doing that. So machine learning driven analytics are collected across a large data set gathered by connected vehicles. Note the word connected, and that's one of the reasons why I selected this use case. So they have vehicles out there, and they're collecting information about safety related to them. So they're monitoring the use of applications and the features to understand which functions the drivers find useful, which are underutilized, and basically which ones are ignored. Furthermore, they're looking at early warning systems, analyzing millions of events every week to work out how they are related to breakdowns, accidents, failure rates of those particular vehicles. So this data then helps them understand how vehicles and drivers react to hazardous conditions. So you can probably already get a sense of what they're going to do with this. They're using this to build their self-driving autonomous models, right? If they know how drivers use this, if they know what the accidents and the failure rates are and the breakdowns, they can start to build models associated with this. So the data that's collected from the sensors, again, connected systems, the cars in this particular associated, are uploaded to Volvo Cloud and shared with the Swedish highway authorities. So as we build not only the cars, but the infrastructure and the regulation necessary in order to have self-driving vehicles, it's going to be important that those two things have to happen in concert. They also have data analytics that are being carried out with a partnership with Teradata. They are also partnering with NVIDIA and AutoLive in order to create a software group that focuses on building safe autonomous driving vehicles that it can include using deep learning to learn how to recognize and react to objects in the car via the cameras and the sensors. Okay, this is going to be our inputs that we're going to use, and then they're going to gather that data and they're going to create a situation map or a 360 view of that particular car. So they're sharing that with the highway authorities, and then they're building the safest model possible for their autonomous vehicles in their cars. So what are the results? So Volvo's data analytics shows them how quickly and accurately to understand faults and errors that can occur with their connected system cars. Service centers, what's very interesting, I talked about the power of AI in terms of how we're going to change products and services for our customer. Service centers can better anticipate the tasks that they will face and adjust inventories accordingly. If they're collecting data in terms of failure rates of components or something like that, they can easily send a correspondence to their service center to stock up on whatever that particular component is. And then finally, Volvo is starting to launch autonomous vehicles. The Drive Me trial in Sweden, it's announced in China and then parts of the US as well. So one more slide here before going to the next use case. What are the key challenges, learning points, or takeaway that we have? Vehicles are becoming more autonomous before we have complete self-driving vehicles, which is going to be the norm. So safety is going to be the key, right? Safety is going to be the key. If properly trained, this is Volvo's approach, they can dramatically reduce the amount of accidents basically caused by human error. So in a theoretical world, we should have a safer environment when we're driving. And they're doing this, again, by using their cars as their IoT in order to be able to collect that data and then build AI models in order to have the safest vehicles on the road. Let's take another use case here. This is Daimler AG, former Daimler Chrysler, and they're really known for luxury personal cars. And in this use case, we're going to take a little different tack. They're working on self-driving autonomous vehicles as well. But in this case, I want to highlight some of the things that they're doing in terms of being able to deliver that car to the end user. So again, they're the parent company of Mercedes-Benz. They've long been known for luxury vehicles, and they're using machine learning to help streamline processes and cut down costs by removing human errors in all the different equations basically that they have in their circumstance. So what is the problem that they're trying to specifically solve? Actually, the use case out of the book references a couple different cases, but I wanted to pull it down specifically to the vehicle production because I think this part is probably the most interesting. So Mercedes is using artificial intelligence to create efficiencies in their vehicle production. If I was on a manufacturing floor, who doesn't want to gain efficiencies? So vehicle design and manufacturing that we all know is labor intensive, it's a costly process. High-tech plants and equipment are expensive and requires a larger workforce. And the flip side of that is equipment breakdowns and human errors can lead to waste of resources, delays, and even potential injuries of their particular workforce. So this is the problem that they're trying to solve. So how are they using this in practice? So they're extending their automation to design, production, and the sale of the vehicle. This is a little bit different than the Volvo use case. So they're using cameras, sensors, Internet of Things, that should sound familiar, technologies, to give the business real-time overview of their stock inventories and operation efficiencies of their machinery. Again, they want to do predictive maintenance. They want to know what they have in terms of their inventories. They want to know how their machines are basically interacting. Again, they're collecting a lot of data in that circumstance. So interesting, prior to this, I didn't even know this. So each vehicle can be built to customer specifications while remaining in a mass production environment. I think that's pretty impressive. So in a previous life, I worked at Harley-Davidson, and they were trying to do custom built motorcycles, but there are only certain variants of that. Mercedes has kind of perfected that. So you can build a custom Mercedes in a mass production environment. And what's kind of slick about it is they have the Mercedes Me app that allows the buyers to be able to track that progress through the vehicle build. So you can create whatever Mercedes you want in a mass production environment. They can custom build that for you. And through the power of your smartphone, you can basically see where that build process is happening right now. That's real customer service. That's real customer service in that circumstance. So what are the technologies, tools, and data sets that are being used in that circumstance? Again, this use case focused more on the production environment. Data is gathered through cameras and sensors. The very things that we're going to be doing research at the Connected Systems Institute about that are connected to machines, as well as data from their computerized stock inventory systems, and then basically customer feedback. So they're using all of this to make better informed decisions about the products that they offer, the production floor that they have, the machinery that they're using, and then the end product that they're using. They are, and much like other product development organizations, are using 3D printing, virtual reality in order to do more effective prototyping designs as well. So what are the key challenges, learnings, and takeaway in that circumstance? I think this first point is pretty poignant. So Mercedes is moving away from a traditional car maker and positioning itself as a data-driven technology company. I want you to think about that. So they're not just a car maker, they're a data-driven technology company. And I would argue a lot of organizations have to be able to move this, right? If they're going to produce smarter products and services for their customer that they're going to demand, by the way, our customers are going to demand that, they have to be data-driven in terms of the decisions basically that they made. So the technologies are implemented all the way from design prototyping to production and then the sale and the service of those vehicles. And at the end of the day, it's going to result in an auto production line that's going to be safer, faster, more efficient, and able to collect and analyze data essentially at every step along the way. A couple more slides here. So what is UWM doing about this circumstance? So 2 years ago, going on 3 years ago, Northwestern Mutual Life had a tech summit, and they talked about a lot of emerging technologies. They bought in large organizations, they bought in small organizations, they bought in startups, related to artificial intelligence, related to blockchain, related to IoT, related to cybersecurity. So in my school, the School of Information Studies, we created what is called the Disruptive Technologies Lab in order to be able to meet the demands of our industry partners. And what's cool about that is just a little blurb about the technology. We have a physical space on campus. We're getting a new physical space as well. It's not as large and nice as the Connected Systems Lab, but I really describe this lab more as a platform where we can collaborate on artificial intelligence, blockchain, IoT, cybersecurity, and the goal is really to do things like this, to run seminars and workshops and boot camps, hackathons. We have on-site facilities, we have virtual labs. I have a 600 level artificial intelligence class that I've created in order to meet the needs of our industry partners. And the most important thing is that we're a collaborator. We're a collaborator with the CSI Institute. We're a collaborator with the new Lubarb Center of Entrepreneurship. I host some of my classes out of that. So it's an ability to reach across campus and work with different disciplines from engineering to business, to architecture, to the Peck School of Arts, because they all bring different skill sets, and then do projects and seminars and collaborate basically related to this area. I mean, again, I think we're analogous to the mobile and the social media platforms and the web. There's going to be a slew of amazing businesses and organizations that are going to be built out of this, and it's going to make our lives much better. So I'm excited to work in this particular area. So I think that's my spiel. The last one, again, I would thank you so much for your time and logging in today in order to be able to view this. And then I will ask Charles or Mary if there are any questions in the queue.
Thank you, Matt. I just want to point out here for the audience that this is I think Matt set it up really well. The Data Sciences Institute has all the power and knowledge about how machine learning can turn data into information. Collaborating with them and turning that attention to manufacturing lets CSI members and team collaborate together in order to turn that energy towards the focus of manufacturing. So this is the big benefit of working with these groups of institutes here at UWM. So thank you, Matt.
That's a good point. I completely forgot to mention the Data Science Center, the collaboration that we have with Marquette.
All right, well, let's jump right into questions. We have a few. So the first is, can you highlight the specific areas that AR are helping with this JIT type application? Some of this technology can often be confused with older automation tech that has been enabling customization plus JTI at companies like Jaguar Land Rover pre-AI.
Say that one more time, Charles. That was a mouthful.
Can you highlight the specific areas that artificial intelligence are helping with this, and the acronym is JIT type application? Some of this technology can often be confused with older automation tech that has been enabling customization plus, and I think they meant JIT instead of JTI, at companies like Jaguar Land Rover pre-artificial intelligence.
I think the benefit is going to come in, and what I'm assuming is they're asking about just-in-time manufacturing.
Okay, so Jason.
Or just-in-time inventory. You know, it's two sides of basically one coin. You're trying to limit whether it's at your main facility or it's at a tier 1 or tier 5 supplier, all the inventory that you're sitting on. What's interesting right now is, so I'll go back to the slide that I talked about, big data. And again, we're trying to extract knowledge from the data that we have. So in the past, you can use statistical methods, and you'd sit on the data science side to say, okay, we need, in order to run lean and efficient in our factory, to run 7 days of inventory. But if you take that data, and maybe you take it over a year, or you take it over, and then you're running some of these AI algorithms, you can deem that, you know, really you can survive with 3 days of inventory, or whatever the particular, you know, circumstance is. So what I would envision happening on factory floors is that, and through the CSI Institute and through some of the research that we're doing, and I know specifically on the engineering side, a lot of this is being done, is that you're monitoring these streams of data, you're putting it through your algorithms, and then you're identifying, you know, clusters of, we don't really need 4 days of crankshafts. We only need 2 days of crankshafts. And as a consequence, you're going to get smarter about the inventory levels that you have inside of your factory. I'm assuming that's what they're asking in that circumstance. So you're going from, maybe I could say analogous to an analog circumstance where you're monitoring those and you know how many days of inventory you have on hand, to a digital world where you're making smart decisions based off of extracting knowledge out of the data that you have.
All right. Next question. How does an engineer already working in manufacturing help their company to use artificial intelligence?
I think probably the first step that I would start is there's a slew of online resources, and maybe in the comments when we post this, we can provide it. Start to educate yourself about, you know, what are some of the algorithms, what are some of the things that are happening in the circumstance. I believe, and honestly, maybe Mary can chime in here, that we are working on credentialing, not only for a data science master's degree across campus, but that will be truly a collaborative activity. So I know this is a question that I get from interacting with a lot of our strategic partners. Essentially, how do we do upskilling? So I think we are working on, we have a master's degree in my school with a data science track, but I think we are looking at providing micro-credentialing, providing more webinars like this that are probably not as you know, survey level, but more in-depth things. And I think we're looking for, you know, ways to interact with our strategic partners so that we can fulfill one of our mandates, which is to educate the community. I don't know if Mary has any thoughts on that one.
Sure, I can expand on that, Matt. Thank you. The whole idea of CSI is to provide that gap, the knowledge, fill that knowledge gap between where academia leaves off and the art of manufacturing picks up. So for the data science degrees, for example, Matt, what we're looking at is how to credential those degrees for domain specific capabilities. So while you understand the basic mechanics of AI and how to build an algorithm, a manufacturing conversation will dwell a bit on context. You know, what's the context of that asset? What environment is it operating in? What kind of a product is it making right now? What's its history of work, right? These are all variables that get cranked into these weighted models that you've described. And those are the things that we'll seek to teach with CSI. And anyone who heard my talk last week, you can't divorce the topic of reliability from the topic of AI because they are correlated. You have to learn the science of both and work collaboratively with a lot of different knowledge brokers to come up with a model that works for you. So hopefully that addresses your question, but I actually have another question, Matt, if you don't mind, you know, in light of all that complexity, right? trying to understand the weighting of different variables that you're pulling into this calculation to assess whether it's a good condition or a bad condition. You gave some examples of quality, right? Is the bolt there or not? Does Domino's pizza look the way it's supposed to? Do you have an opinion? Some manufacturers are trying to tune those AI models from the bottom up. In other words, this is bad, this is good. Other manufacturers take a different approach where they just simply look for anomalies. So this is a good picture. Anything different from this is a question. Do you have an opinion on the success of one methodology versus another, or how you would decide on which teaching methodology to use?
I think you have to start from somewhere, and maybe that is just determining is this good or is this bad, and then as you grow your expertise, as you grow your organization, again, you're collecting a lot of information, and then you're trying to deem some knowledge out of that. I haven't seen. I think if you take a look at the circumstance with Daimler or with Volvo or with any of the manufacturing use cases, organizations are struggling with this. I mean, that's why I started with the Wall Street Journal or the Forbes article to say, everybody's racing to try and implement these things in, and we're still early on. So I wouldn't feel like one size fits all for organizations, but you have to start somewhere, and you start small with a project, you run your data, you get some success under your belt, and then you build it from there. I'm not quite sure if that answers your question, but I haven't seen, I don't think one formula is a success for all organizations. I don't know if that makes sense or not.
Yeah. Actually, this is related to a question I'm seeing come in here. Charles, you might have been tuning in on this one. Are there specific resources or platforms that you recommend for data mining and analytics? So I almost think those are kind of two questions, right? Because data mining and cleaning and contextualizing data is almost a whole topic on its own. But do you have any advice for that listener?
Boy, I guess I would take a look at what kind of shop you have right now. I can tell you from my experience over the last couple of months, and I am not one platform or one tech company agnostic, but we do a lot of work with Microsoft because we're a Microsoft shop, and I can tell you from working with a couple AI MVPs that they're throwing a lot of resources at this. So is Amazon, so is Google. So I think it's like evaluating any industrial software package. You have to take a look at, what kind of shop you are right now, and is it appropriate to implement tools? I'm telling you right now, Microsoft is working previously behind the scenes so that you don't have to be the algorithm expert. You have to be an expert in your business model. And Google is doing the same thing, and Amazon is doing the same thing. And I would recommend, like any project, if you're going to spend a significant amount of money, doing due diligence in that area. And then there's a whole slew of other open source. There's R and there's Python, and it really depends on what kind of shop you are and where you are. And I'll give you an interesting example. Is that one of the reasons why, a little tangent here, is we're slow to get some of these stimulus checks coming out, is because some of those applications were written in Cobalt. So if you have an old organization that has a mainframe, maybe implementing a new Microsoft solution won't work. So you have to take a look at what you have, and maybe you're tied to that legacy system for a long time. I would, probably recommend taking a look at where you are and what makes sense in order to be able to implement it. There's a lot of fantastic solutions. You got to do some due diligence though.
All right, we have a great question here. From a manufacturing perspective, as customer demand becomes personalized with smaller batch sizes and custom delivery, do you see the emergence of autonomous manufacturing cells that can be deployed closer to the source of demand, not necessarily large manufacturing, but applied to small and medium manufacturing?
I have not personally seen anything of that. If that makes business sense, I certainly think you can do that. We seem to have a pretty efficient logistics system. I know that Amazon can be challenging to work with sometimes in terms of being able to deliver products and services, but I would think, at least from my past experience, having a factory and having that expertise and even that tribal knowledge would maybe be more important than a location. We can still ship pretty effectively. In fact, one of the benefits that we're going to get, there are trials of self-driving autonomous trucks right now. So I would think it would be easier to have a base of expertise, a facility that you're comfortable with, and then being able to distribute literally globally. That would be my guess. I'm not a custom manufacturing expert.
All right, an ethics question on AI and machine learning. Considering the research done on gender and ethnic bias in algorithms and code, how is the artificial intelligence machine learning sector working to avoid embedding biases in the system?
This is an exceptional question. So I spent an entire class period on talking specifically about this. So this is analogous to talking about, when you write a program, garbage in is equal to garbage out. There have been many classic use cases, especially related to some of the larger tech companies, about bias in some of their algorithms. And the problem that they had is the algorithm wasn't flawed. It was the data essentially that they were feeding into that. So I think the answer to that, in fact, I will give UWM a ton of credit, because through the Lubar Center of Entrepreneurship, they had a pop-up session and they brought in an ethics expert related to this, talking about some of these biases. And what's going to, I think, in my opinion, be required is that it's not only a technical decision and a management decision, but there has to be a social science aspect to it. There needs to be somebody in the organization to say, is our data, and again, at the base level, if we're teaching these algorithms from experiences or from data, is it reflective of what truly is the values of our organization, including a diverse workforce and a diverse customer base? So you need not only data scientists, but you need social scientists who are asking those important questions, because you might be, disenfranchising a lot of your customers because of that.
All right.
Let me expand on that answer a little bit, commenting on bias in data sets specific to manufacturing, because I almost think this question is, there's a social aspect of it, but then there's the pure data science aspect of it as well. And this goes back, this is sort of related to the question that I had earlier for you, Matt, about teaching models, right? If you are starting your machine learning journey from a completely unknown space of what indicators tend to lead to bad, then you're reliant on a data sample set which is widely arrayed and with a careful viewpoint on any bias that might be in that data set to begin with. If you're starting your teaching model from this looks good all the time, then you're somewhat eliminating that risk because you're focusing only what's good. But again, to your point, Matt, that only works in instances where it's appropriate for your particular application. So you really have to think about where you're applying that. But I just wanted to call that out as a piece of decision criteria that anyone listening here on the phone needs to consider when you're putting in place AI-based projects.
All right. Well, that's all the time we have for today. Thank you, Matt, and all our listeners for your great questions and active participation. We'll be posting shortly the recording from today's session on the CSI website events page. You can access it there, hopefully today, by tomorrow at the latest. I will invite you to tune in next week on April 30th, when we'll hear from Kevin Clark, VP from Fluke Reliability. He joined Fluke in 2016 and has 30 plus years of industrial experience working with both Fortune 500, and smaller startup manufacturing and technology companies, serving in various leadership capacities. Kevin will discuss that as machines become more complex, decisions about where to apply monitoring technologies become more complex as well. How have measuring devices such as vibration sensors become digitalized? What is the future of digitalization for all types of measuring devices? How do you determine which data is important to store or not? Please register for this event at uwm.edu/csi/events. You can also register for events through our Connected Systems Institute LinkedIn page, which you can see right here on the screen. Go look for events and it'll take you right to our registration site on Eventbrite. My name is Charles Mosley, your host, signing off for today. Thanks for attending, everyone. Thanks for your questions.
Thank you, everyone.